The sum of the first n terms of an arithmetic progression is n squared plus 2n. Find the n term of the series. Find also the number of terms whose sum is 575. Okay, for each of the series, find the set of values of r for which the series is convergent and find the corresponding sum to infinity of the series. Okay, let's start with the first part, which is finding the n term. Okay, so the sum of the first n terms is given as n squared plus 2n. And they want us to find the actual n term. Now, the n term of any arithmetic progression, the n term of any arithmetic progression is a plus n minus 1 d, which is a common difference. So we need to find a, the first term, the second term, and we find the common difference. Okay, so now let's go ahead and find about the sum of the first 1 to 3 terms, right? So the sum of the first term, well, it's just going to be the single term, so that is the same as the actual first term, right? Okay, this is going to be when n is 1, so that will be 1 squared plus 2 times 1, which is 2 plus 1, which is 3. Okay, and then we have the sum of the first 2 terms, which is basically 2 squared plus 2 times 2, which is 8. But keep in mind that if you want to get the second term, since we already know the first term, want to get the second term, like so, what do? We take the sum of the first 2 and we minus the first one. So we take the sum of the first 2 and the first one. That gives you 2. Lastly, sum of the first 3 terms would be 2 squared plus, 3 squared plus 2 times 3 equal to 9 plus 6, which is 15. And yet again, the third term would be the sum of all the 3 minus the sum of all the 2. 15 minus 5. Sorry, the sum of all the 2. Okay, minus 8, rather. Okay, that's 8. And this would be 15 minus 8. Okay, I'm having a brain freeze, which is 7. Okay, our sequence would be 3, 5, 7, and we can definitely see a pattern. So the common difference is 2. And finally, n term is going to be 3 plus n minus 1, common difference of 2, 3, common difference of 2, 3 plus 2 n minus 2, so 1 plus 2n. That's our n term. And then find also the number of terms whose sum is 575. The number of terms whose sum is 575. Whose sum, so the sum of the number of terms whose sum is 575. In that case, we have to do n squared. We just equate n squared plus 2n equals 575. This one is actually pretty simple. Okay, sum of n terms, which is 575, and we saw that it's n squared plus 2n equal to 575. Okay, so this is the quadratic, and we can use the quadratic formula, all right, since the number is really huge. Okay, quadratic formula would be n. I'm not going to write that down. We have negative b, which is 2. So this is a, this is b, this is c, just in case. So negative 2 plus or minus square root b squared, so 2 squared, which is 4, minus 4a, which is just 1, c, 575, over 2a. So n equals plus or minus negative 2 over square root of b2304 over 2. Square root of that would be 48 over 2. And then we can work out the values of n. Negative 2 plus, why did I still put the square root? I don't know why, but it should be 48 over 2. And then this first one would be 23. And n, well, we don't even need to work out the second one because you cannot have negative terms. All right, there's no way we can have negative terms, so this one does not work. So the sum of the first 23 terms should give us that value. For a series to be convergent, the magnitude of r has to be less than 1. What does that mean? Negative 1 should be less than r, should be less than 1. Okay, so they want us to find r for each of them. We have to find the common ratios. So for series number a, if you want to find the common ratio, you just take the second term over the first term, third term over the second term. So 1 plus r over 1 should be equal to 1 plus r, all of this squared, over 1 plus r. So then common ratio should be equal to, okay, this looks weird because there's 2r, so I'm just going to put this as c. Common ratio should be just 1 plus r, right? And now for the first series, for it to be convergent, the magnitude of this, so magnitude of CR, has to be less than 1. So I'm just going to substitute it using this notion. Right over here, I'm going to have negative 1 should be less than 1 plus r less than 1, right? Then we work out the value of r by subtracting 1 on all the sides of the equation, so that this would be negative 2 should be less than r less than a 0. That's the first one, right? And then for the second series, wait a second, okay, this would be 1 over 1 plus r divided by 1 should be equal, I want to just centralize this, it's always good to have a center, should be equal to 1 over 1 plus r squared over 1 over 1 plus r. Well, it's pretty obvious that the common ratio would be 1 over 1 plus r. All right, so the magnitude of this again, magnitude should be less than 1, so this would imply 1 over 1 plus r less than 1 less than minus 1. Okay, so I'm just going to break this up into two parts. All right, let's start off with this side. So we have 1 plus r times the negative 1, right, should be less than 1. And then we have negative 1 minus r less than 1. I would just take the r to the other side of the equation so that it becomes positive and bring the 1 to this side, so it becomes negative 1 minus 1 less than r, okay, which is negative 2 is less than r. That's the first part. Part number 2. So I'm going to take the right hand side. 1 over 1 plus r should be less than 1, so that we do 1 is less than 1 plus r, and then I minus 1 here, minus 1 here, to get 0 less than r, which means r is greater than 0. Oh, no, which means, yeah, r is greater than 0. So the first solution was -2 less than r. Second equation was r greater than 0. Combine them together, I should get my solution. -2 less than r, since these are in the middle, less than 0. And that looks okay. Perfect. Moving on to question